Hello everyone, welcome to the launch material of Ericsson's dual mode 5G Cloud Core. My name is Victor Ferraro. I'm working as a strategic product manager for 5G core networks in Ericsson. The agenda of this presentation consists of four main subjects. We will start looking and exploring the new business opportunities that service providers are going to face over the next years and what do they mean from the core network point of view. Then we will go into the solution that we are launching. What is the proposition that we are making with this launch? And then going into a level of details on how we are enabling this evolution and what are our key and unique differentiators that we bring from Ericsson. And then we will go into a little bit on where we are in the market side and on the customer side with the solution that we are launching here. As you see, be first to market is one of the important subjects that we will uh, continuously address during the whole material. Let's start looking at key growth figures from Ericsson's mobility report. Mobile data traffic is expected to grow 5 times up to 2024. The growth will happen both on 4G and 5G networks. 5G will account to 25% of the total traffic in 2024. In the same period, smartphone subscriptions will grow 2.2 billion with an even split growth in 4G and 5G, while we still see a drop in 2G and 3G, but it's still close to a billion that will require support. This shows a clear shift of users from legacy networks to 4G and 5G, driven mainly by mobile data consumption. Service, service providers' networks will need to accommodate both 4G and 5G traffic growth for many years to come. It means more packets, faster speeds, lower latencies, doing more with the data, but also the need of handling the growth in a much more efficient way. Let's look at how 5G expands the addressable market, enabling new revenue streams. With 5G, a lot of new opportunities start to open up. Here in this slide, we see four main categories of opportunities. So if we start from the bottom part, from the left-hand side, enhanced mobile broadband. It is the first use case for 5G. 5G opens up the opportunity for mobile broadband services redefinitions, tailoring the offers with unique and richer user experience levels, based on new applications, based on virtual and augmented reality, gaming packages, 3D hologram calling that will require higher bandwidth and lower latencies. Users can feel that they are unique, and this can remove a lot of today's consumers' frustrations. Fixed wireless access. It represents new revenues for operators. 5G can provide connectivity for households and small medium enterprises using wireless technologies. Main addressable segments are the unserved areas, connecting the unconnected, and wireless fiber, cutting the cables. Industry digitalization, looking at the bottom part, at the top part. 5G opens opportunities for operators to address up to approximately 600 billion US dollars globally in 2026. This represents a potential to add up to 36% growth in revenues in 2026, with manufacturing and energy utility sectors representing the biggest opportunity for revenues created or enhanced by 5G. A big share of this is connected to new use cases that are not achievable with existing 4G networks like industrial robotic, self-driving autonomous cars, or remote surgery. Let's now have a look to the technology scene. What is then needed from a future core network meeting the requirements for these new revenue streams? 5G technology will be crucial, but it cannot address all the needs by itself. 5G will take the central role in this ecosystem of opportunities, addressing the full scope of this, enhancing existing technologies, incorporating end-to-end network slicing and mobile edge computing. To harvest the most of these revenues opportunities with efficiency, service providers will need to build networks that combines the best characteristics from new and existing technologies. There is also a lot of 4G needs here. Anything you do on an enhanced mobile broadband for many years, there will require a 4G, 5G tight interworking. Take, for example, the case of VoLTE services. Massive IoT, LTE-M, and narrowband IoT are significantly important because the GSM massive IoT devices cannot just be turned off. Critical IoT brings new things with needs to be addressed in 5G with ultra low latency, really new feature targeting that type of critical IoT segment. But equally, also private LTE is becoming increasingly important in the market as well as edge computing. Another important area to look, um, it's about standardization. As you see in this slide, 3GPP has specified different options for the core network to support the 5G radio access. If we look at the bottom of the slide, sorry, we will have terminals that support, I mean the orange ones, terminals that support all variants, all options with all the stacks there. If you go to the right-hand side, we have a massive amount of LTE EPC terminals today, and in the middle part we see the blue terminals that are the ones that are equipped with non-standalone capabilities to support the 5G access. So at the end of the day, we see that the two core network variants will need to coexist for a long time, and it will be very inefficient for operators if they need to manage them in a different way. So that's why a dual mode operation is so important. And that's why it's so important the ability and the capability to migrate in a control and safe way users and services based on what type of terminals, what type of services are available, what type of access networks are available for them. Based on the business opportunities that we have been explaining before, let's look at the Ericsson solution for 5G core networks. Our main proposition is basically saying to be first in 5G, first get to the core. To help our customers in their journey to build more programmable networks to reduce OpEx and operational inefficiencies, address the new business prospects with agility, and manage the growth and evolution with CapEx efficiency, Ericsson launches its dual-mode 5G Cloud Core solution. The Ericsson dual-mode 5G Cloud Core is a solution that combines 3GPP EPC and 5G core network functions into a common cloud-native software platform, supporting the new 5G NR standalone as well as 5G NR non-standalone, 4G, 3G, and 2G access technologies. The solution is composed of 7 new products that smartly combines network functions based on the services they deliver to the core network. Built on cloud-native technology, it ensures capacity, elasticity, agnosticity to underlying infrastructure, and high levels of orchestration and automation for operational efficiency, only enabled by a microservices architecture. We at Ericsson understand our customers' concerns and needs to protect already done investments in their networks. With that in mind, we design a solution that allows a full integration of the new cloud-native network functions with legacy, virtualized, or physical 4G EPC network functions in the same network and offering different migration paths to bring then those legacy network functions into a full cloud-native dual mode over time. This allows, for example, a gradual introduction of new 5G core network functions, while existing 4G network functions are migrated to the dual mode cloud core native platform. This gives our customers also the flexibility to decide where and when it makes more sense to evolve based on their business objectives. The main challenges that service providers have today is how do they evolve from the existing core network into a future core network in a smooth and safe way. We provide a proposition to address challenges related to managing the growth with CapEx efficiency, reducing the OpEx and operational efficiencies, and growth revenues with agility and speed. We provide one core network to manage 4G and 5G traffic growth with investment reuse. We provide here a high capacity in the user plane, high scalability and flexibility to be able to manage 5G high peak rates in a fully loaded user plane scenario. We provide high resilience and flexible data storage, supporting network slicing and distributed cloud use cases. When it comes to OpEx reductions, we provide one cloud-native software platform for 5G EPC and 5G core. Operational maintenance are simplified with automation and with uniform interfaces and protocols across all products. We provide flexibility to manage the growth of the traffic 4G and 5G, making possible to distribute it where when needed in the system. And we provide automated lifecycle and service provisioning solutions. We provide the fast time to market to the launch of for the launch of 5G services. We provide full set of exposure capabilities, opening with open APIs, opening them in a controlled way, enabling a partner ecosystem for innovation. And we fully support network slicing solution, which is customizable per use case. Now let's have a look to the solutions benefits. With dual mode cloud native operations, efficient service chaining, and 5G peak rates handling in loaded systems, we are able to reduce CapEx in infrastructure, reducing up to 20% savings in infrastructure and 30% less user plane footprint. With our automate software deployment with containers and with common processes and tools, we can cut down the times for installation, configurations, upgrades, and capacity scale of network functions. We reduce OpEx for software upgrades up to 90%, and we provide cost savings in network functions integration, including traffic and operational maintenance integration, up to 75% compared to existing situation in EPC. And also, with network slicing and network exposure, we can grow revenues. Here are some figures that we have provided from some studies that we did with some operators. We can grow revenues by 35%, enabling network slicing, and 2% ARPU increase enabled by network exposure. Let's have a look to the inside. What is inside the different products of the dual mode 5G cloud core? In this slide, you see the standard network functions based on 3GPP definitions, which is covered under each of the different BNFs. As we said, we combine EPC and 5G core in one system. We provide smooth and low-risk 5G core network solution to turn on 5G use cases and create service offering for consumers and industries, including network slicing and exposure, while managing data growth with best cost of ownership and fast time to market with single capex. We have architect all the solution fully cloud native, microservices based, ensuring full interworking with legacy networks and network functions. These combinations allow service providers to manage EPC and 5G core functionality in one system. With this combination, we also provide operational and resource usage efficiencies and right sizing and distribution of network functions and distribute when and where needed in the network. Regarding availability and roadmap, we are starting end of Q2 19 with commercial availability for a cloud-native 5G PC and cloud-native 5G core functionality. In Q3 2019, we are extending this and creating the dual mode operation on top of the existing network functions. The solution will be enhanced, adding further additions during 2020, basically including functionality coming from 3GPP, including also functionality to support non-3GPP accesses. In this section, we're going to explain how we are enabling this evolution with more details around the solution. The message here is getting quickly and easily to the 5G core. We start with cloud native and microservices architecture. All Ericsson cloud native applications are built on the Ericsson cloud native design principles, methods, and tools. We ensure common design rules, common architecture principles, common reference orchestration platform, common set of platform services, and common and powerful continuous integration, continuous development, and deployment pipelines. The adopted design principles that we are taking in the 5G dual mode cloud core are, first of all, agnosticity. We run the applications in any cloud infrastructure, whatever container platform and infrastructure combination. Decomposed software. We leverage on containers and microservices architecture. Application resilience. Fault tolerance in applications and services supporting combinations of failures at any time without escalations to full restarts and loss of service. State optimized design. Decided based on the type of state data and the application context. A state-optimized design considers the impact severity of a state data loss to the function of the cloud-native architecture, the impact on the user experience, but also the cost-benefit considerations on frequency of changing states. Orchestration and automation. We provide fully automated lifecycle management of internal microservices. Some examples of automations are auto-scaling, auto-healing, and upgrade containers orchestrated by Kubernetes. Let's go in one of the key aspects of our solution, that is deployment flexibility and smooth evolution, enabled with high automation and with unified operational maintenance. As you see in the slide on the right-hand side, we provide deployable BNF artifacts. They consist of a full set of application microservices that implement the business logic of a set of network functions as you see in the graph with different colors, purple, orange, and blue. These microservices are running on top of a set of common services providing operation and maintenance capabilities that are common across the full portfolio. You can see them represented with the green color. The common microservices for operation and maintenance provides uniform operation and maintenance no matter what the network function is. Each network function is actionable by means of orchestrations. This also means that the operation and management interfaces are programmable, incorporating all configuration management, performance management, fault management when the network function is activated. So now you don't need actions anymore on a per 3GPP node basis. Actions are done on an aggregated set of 3GPP nodes. We provide also automation for lifecycle management with workflows that are exactly the same across the portfolio. You can allow complete group of network functions or a complete network slice to be deployed in one orchestrated way. Another aspect is supporting the gradual and flexible evolution to 5G. Earlier on in the introduction, we spoke about what we call long tail of subscribers in 2G, 3G, and 4G. There is a strong growth on LTE as well on the 5G side, meaning that the functionality need to be able to support even in situations where the device here with an option 3, for example, non-standalone, happens to leave the LTE coverage and the only available coverage is 3G or something else. You have to make sure that services and user experiences can evolve without disruptions. You have to make sure that the music bundle package will still work in this scenario. By evolving your core network, uh, we are enabling this. You can start introducing this with option one being LTE devices. Then move on and introduce option three, non-standalone, with 5G PC by adding new microservices and continue adding new microservices for 5G core as you move into option two, standalone, with a truly dual mode core. The total network capacity can also easily manage and move across the different accesses according to the traffic seasonality and migration from one generation to another one. Let's now describe a bit better a key property or key capability, which is network function runtime evolution flexibility, and take the example of the packet core controller. Similarly, as we saw migration from physical to virtual, we could see that, for example, the MME migration and full expansions. This was when we had the physical pool started to introduce virtual MMEs. We saw that how we introduce it in a lot, probably or 20, 30 tier 1 selected in the initial approach. They got into cloud, they did capacity growth on the cloud side. Similarly, here we can do now a cloud native MME in the controller. You can do the ground time, just increase MME capacity. Then starting from here, you can add and move forward and add the AMF capability based on the 5G core capabilities. And then ending up adding the gateway functionality, the gateway control functionality, creating a full set packet core controller which is composed by all control capabilities for access, mobility, and session. This is one journey, but there could be some others. Take, for example, the case of COOPs as a key introduction factor. We can start with the control part of COOPs and then progressively add the SMF part from the 5G core and ending up again in a full set packet core controller including MME and AMF capabilities. Another starting point could be a 5G core control plane, full overlay composed by AMF and SMF, or an EPC control plane where you are going to modernize and add capacity growth based on container-based MME and gateway control functionality. So at the end of the day, there are different alternative paths for varied types of business needs. We can support different needs from different types of organizations in the operators, depending on how they are operating the networks today, for example. So in simple terms, this is showing one of the network functions of the packet core controller as an example, and how it can be done in a very flexible way, enabling different types of evolution alternatives. Another important capability we are bringing is network exposure. This is to foster business innovation. How do we get more speed? How can we really bring new services into the market? If you look at the service-based architecture here in this slide, you see in the lower right-hand corner of the picture that there are many different interfaces to each network function of service. It's now possible to aggregate information from these interfaces in a dynamic way, creating different business logics visualized by the blue dots. These or they can be exposed to the API gateway to compose specific services APIs and expose them to external developers that can build new services on top of the mobile network. It is like an application store that exists for mobile phones, but in this sense, it is a network store where new innovative services can be created and quickly deployed, making use of standard mobile network capabilities. The Ericsson Cloud Core Exposure Server implements network exposure functions to open up core network capabilities to third parties, an Ericsson API gateway solution that creates and exposes unique service APIs tailored around a specific application use case for new revenues, centralized management of different network APIs, standard and customized 4G and 5G for advanced network programmability, and APIs can also be exposed internally to the network for more automation and operational efficiencies. If we look now at the lower part of the solution, we find the user plane with our packet core gateway. The packet core gateway provides a high performance user plane to meet the 5G demands. It provides two key capabilities. One is high capacity to manage the 5G peak rates in a loaded system. And the second one is an open and flexible user plane with internal service chaining, where we can provide or we can support both Ericsson and third-party value-added services, enabling flexible selection of functions. One of the most common problems in user plane that is already starting to become visible in LTE is that there is a lot of heavy peak rate evolution. The problem, of course, have been in the area of how you can keep a loaded system up and running and then still on this system sustain individual devices that are going up with very high peak rates in temporary. We are supporting individual peak rates of 20 gigabits on the downlink and 10 gigabits on the uplink per user equipment. So for operators launching 5G and operators that have all the spectrum available, they can offer this type of peak rate services and they can do that on a loaded system, and this is reached with a unique flow based load distribution that we have implemented in our packet core gateway. As I said before, we provide a very open and flexible user plane where we can add service functions to enrich the services on the GI interface. This provides very important benefits in terms of footprint reductions up to 30%, and also it lowers the integration cost for functionality on the GI interface up to 40%. Now we look at the top part of the solution, which is the data storage area. Here we provide high resilience and flexible data storage services through the Cloud Core Data Storage Manager. Our database system is designed to cope with all needs from cloud-native design, as, for example, flexible data structures, but also it keeps all the telco-grade robustness mechanisms that are not that common to IT databases, as data redundancy, replication and consistency, and triple multi-geo redundancy. It also implements the Ericsson unique cooperative overload protection mechanism between the database and the logic frontends. It's a completely dual mode database system, meaning that it supports subscription data for all different accesses and have interworking with legacy databases for full reuse of existing capabilities and simplify migration to 5G core over time. In some industry cases, for example, it will be important to have a user provisioned locally to sustain operations in case of a total transport outage. And our Cloud Core Data Storage Manager allows you to have a way of slicing the data in different network slices. Now let's go to the last section of this presentation, where I would like to focus on our experiences and achievements from the last years working with leading service providers on this journey to 5G. As you say here, the key message is experience, trust, and integrity. In this graph, you can see that we in Ericsson have a strong business momentum with several first mover contracts and numerous proof of concepts and trial engagements going on. Up to date, we have 16 commercial contracts for 5G, where we can name some of these customers as Verizon, Swisscom, Wintre, Telenor, and Telstra. This number is a mix of 5G EPC and 5G core contracts, with some already live with 5G EPC. We have also engaged in more than 55 trials and proof of concepts with operators, industries, and institutes worldwide. Here are some references of tier one operators where we are working and key markets where we are showing our forefront position for 5G EPC and 5G core. Verizon was the first carrier in US that go live with a 5G EPC network to deliver fixed wireless access, and we have delivered key network functions as part of the packet core network. We're also working a lot with China and China Ministry of Information and Technology, where we see that is one of the key leading markets for a standalone introduction of for 5G. We have been passing 100% compliancy presented by MMIT in terms of 5G core functionality requirements, meaning that it's a software that has been well developed with pre-standards when standards were also not yet completed. And we have been able to run this with high percentage of compliancy rates for a 5G core standalone operation. So we are highly engaged in the China activities, and as you see here, MMIT has publicly announced some of the vendor testing results, and we have passed 100% compliance, as you can see here in the screen. Here you can see also some quotes from Swisscom taking Ericsson's dual mode 5G cloud core to enable the evolution of from 4G core to a combined 4G and 5G network. Some of the quotes from SK Telecom, where we are helping them to reinforce their position to become leaders in 5G, extending 5G network capabilities to support the new NR standalone access. Also, we are getting good feedback from analyst community. Here is some quotes from Avon, where highlights that Ericsson strengthens its end-to-end 5G platform with a multi-access cloud-native core network solution. Okay, so now we have approached the end of the presentation. Here is the summary, and I would like to highlight 3 reasons to embrace Ericsson's dual-mode 5G cloud core. As we have said, we provide one core network solution for 5G as well for earlier generations to be able to handle the growth of the traffic 4G and 5G, to handle it in an efficient way, and to be able to scale quickly to 5G business opportunities. We provide cloud-native software with automated capacity elasticity, with efficient and robust operations. We provide APIs to unlock the core network capabilities, to attract business innovation, to attract partners, to embrace realization of network slicing and edge computing capabilities for a full set of use cases and business cases opportunities. And we are a reliable partner. We have product capabilities widely used, widely deployed. We have a wide experience already acquired in early 5G deployments with leading markets and leading customers. So this is all. Thank you very much for your attention.